Creating and replacing a tool. In this video, I'm going to show you how to take either geometry that's been provided to you or geometry that you've created in a external piece of software and turn it into a tool that can be then attached to your robot in an existing simulation. Let's get started. So here's the simulation that we're going to use for this example. I'm going to pan around and zoom in a little bit so you can see the simulation that is running. So this is one that I had created in a past video. And when we run this, the pen tool runs all the way around the exterior and then runs the curve of this object. So this is the simulation that we're going to run in a few minutes. So in order to create a tool, I like to do this outside of the simulation that I'm working in. So I'm going to create a new empty station. I don't need to save this because I haven't made any changes since I opened it last. So we're going to create a new station. And now that our new station is created, we're going to import the first geometry. Now on the robots that we use within our facility, we actually have a tool changer assembly, and the tool changer assembly allows us to swap one tool to the next without having to actually go into the work cell, shut down the robot, and do all kinds of things like unbolting the tool, disconnecting the wiring harness, things like that. So what I'm going to do is I'm going to use this tool changer assembly to show you two different methods of creating a tool, and also how to create a tool for a tool changer. So the first thing we're going to do is we're going to create the robot side of the tool changer. So I've modeled this outside in SolidWorks, and I imported it as an SAT file. And you'll notice that when I import it, it actually imports a portion of the tool or a portion of the geometry here underneath or what looks to be the floor. This floor is actually the user coordinate system. But when you import anything, it will import at the user coordinate system 0 or the world coordinate system 0, which is normally synchronized. So here's where that tool gets imported. It's not a tool yet. Right now it's just a geometry. So if we go to the Layout tab, we'll see that we just have this geometry created. So to turn this into a tool, we're going to go to the Modeling tab. By the way, you can actually create your own tools within Robot Studio using solids and creating surfaces and things like that. But we're going to use these from an external source. So in order to create a tool, we're going to use this create tool function. I'm going to grab that, and I'm going to give my tool a name. So I'm going to call this tool changer. I'm going to say that I want to use an existing component. And here's where Robot Studio will see all the various different bodies and materials and objects that you have within Robot Studio, and it will list them here. Of course, we only have one, so we're going to select the one that we have. And I know from measuring the real tool that this has a mass of about 0.4 kg. So I'm going to put in 0.4 kilograms for my mass. And if I knew the center of gravity of this part, I would punch in the center of gravity. But since I don't, I'm going to get Robot Studio to assume that this is all uniform density and that all the holes are placed correctly and everything like that. And we're going to have it calculate where the center of gravity is. Now, in order to do this, you want to select the part selection tool, and we're going to pick Snap Gravity. Then we'll select our center of gravity here in our tool creation and pick the object that we want to grab the center of gravity of. and it will put in approximately what it feels the center of gravity is. We're going to say next. And now we're going to go on to adding the Tcp frame. So the Tcp frame is essentially where the tool center point is in the robot. By default, your robot will navigate around using tool 0, which is kind of the center of the front of the flange of the robot arm. Now, in order to be able to dock with an existing tool when you're using a tool changer, it's really helpful to have the mating surface of the tool changer defined as a tool itself. So we're going to add this now. So I'm going to say the TCP is my tool changer, and I want to grab the center of this kind of face. So what I'm going to do is I'm going to go to surface selection and snap center. When I do this, I can then click on the position and click on the surface that I want. And if I pan around, you'll notice that it's put a crosshair right in the center of that hole there, which is correct. So I want to say, or go over here, and I'm going to look at this Z value, and I want to take note of what the Z value is, because it's going to come in important in the next tool that we're going to create. So we're going to say the tool is good. We're going to say this position is good, and we're going to move this over to the TCP. Now you can have multiple TCPs created for a single tool, and there's a lot of cases where we might do this. In this case, we're just going to have one TCP. So now that I've moved this over, I can say done, and it's turned this into a tool. Now that this tool is created, I can right click, and I'm going to save this as a library component. I'm going to just save this to the default library location, which is on my computer under my user, documents, Robot Studio, libraries. You can save it wherever you wish. Just keep in mind where you've saved your tool. And now if I go over to my Home tab and go to Import Library under my user library, there's my tool changer. So let's now hide this tool. We'll make it invisible. And we're going to bring in the next geometry that we're going to do. So I'm going to go to Student Geometry, and I'm going to pick the Mig Torch. Now the Mig Torch is going to be much more complicated because the TCP is not centered over the base of the tool. The mass is going to be somewhere very strange in relation to the tool itself, or seemingly strange. And I also don't want the z-axis to be perfectly in line with the z-axis of the world coordinate system. So in order to do this, the first thing that I need to do is I need to keep in mind the fact that this actually attaches on top of that tool changer. And since the robot itself can only have one tool attached at a time, you can't have a tool on a tool on a tool. What we need to do is we need to take this tool and we need to offset it based on the distance that it would be from the tool changer. So I'm going to right click on this, and I'm going to say position, offset position. And if you remember from the past tool that we created, we know that this is 34 millimeters in the Z off of the base position, or off of tool 0. So now I've got this set up at the correct position so that my TCP lines up. If I didn't do this, my robot would actually move closer and crash my tool through the table, because my TCP would come out 34 millimeters lower than the actual TCP is supposed to be. So keep this in mind when it comes down to creating compounding tools within Robot Studio, and especially if you're going to move it over to the real robot later on. So now we're going to say create tool, and I'm going to call this my MIG. I'm going to say I want to use existing, select the Mig Torch assembly, and in this case for the mass, we need to keep in mind that because of course we can only have one tool attached, we need to think about what the mass of the individual tool is that we've actually got here, which is in fact actually for our tool 0.6 kg, and we also need to think about the mass of the other tool that was attached, which is the tool changer. So in this case that would be 1 kg for the total, or for both of them. I'm going to go to the center of gravity, and ideally I would actually have both tools here in the simulation and grab the center of gravity of both. But in this case, I'm going to just use the center of gravity of this tool for now. There we go, we've got our center of gravity. Move over. And there's something that I forgot to do, which was actually to create a frame. So what I'm going to do is I'm going to cancel creating this tool, and we're going to go back and we're going to create a frame. The frame is going to make it way easier to define a point up in line with the wire that's coming out of this MIG welder. So I'm going to say frame. I'm going to use surface selection and center because I want it on the center of this. So I'm going to put my cursor in my frame position and select that surface and create and close. Now I've created a frame. This will make it much easier to define my tool. However, you'll notice that the Z-axis is vertical instead of being in line with my wire here. So to fix this, I'm going to zoom in and I'm going to adjust the positions of my frame. So I'm going to set this normal to the surface. I'm going to select that flat surface on the end of the wire to be the normal surface that I want it to be normal. Then I'm going to right click and I'm going to rotate this because I actually want my x-axis to be in line with the rest of my tool. So in order to do this, I'm going to rotate this about my Z, and I'm going to rotate it by 45 degrees. And that puts my x-axis in line here and my z-axis in line, which will allow me to position my tool correctly. The next thing that we're going to do, now that we've created this and created a frame, is we're going to create the tool. So again, if you remember, I created the tool called my MIG. I want to use an existing. We're going to select the body, select the center of mass. There's the center of mass. And say next. And this time, instead of picking a position, I'm going to say values from target frame. I'm going to say values from frame 1. And move this over. Now what that's going to do is that's going to grab these, or the orientation and position of this frame, and bring it in to Robot Studio here and line it all up for me. Then I can say done, and I've got my tool created. I can now delete that frame because the frame is saved as part of the tool, and I'm going to save this as a library component. Go and double check that it exists in my library. And there's my MIG and my tool changer. So now let's open up that past simulation. So we're going to say open that simulation that I had before. No, we don't need to save any of the changes because we've defined these tools and we've made them as a library component. And now we're going to attach this to our robot once the controller starts up. So we're waiting for it to say started. There we go. And the next thing we're going to do is we're going to grab our robot from the layout browser here. And we're going to go move to pose and jump to home. That's going to move our robot to the home position. Then we want to swap out this pen with our new tools that we've created. So I'm going to delete the pen. And you'll notice that the TCP for the pen stayed. That's because I didn't delete the pen out of my solution yet. It still exists here. There's still the pen TCP, and it's bolded because it's in use. So we're going to leave that until we've brought everything else in. So now we're going to import library. Go to my user library, and I'm going to add my tool changer. From layout, I'll attach my tool changer to my robot. Then I'm going to, again, go import library and bring in my Mig Torch. And I'm going to attach my Mig Torch to my robot. And now my TCP is lined up where it should be. Next, in order to change these tools within my paths, I need to go to my path, select all the points in my path, and I'm going to go down here and I'm going to say modify instruction, tool, and I want them to all be my MIG. Now when I do this, you'll notice that off the start here, we've got some configuration errors. It says this may not be reachable with the current configuration. So let's open up those points and see why that is. Let's make all those points visible. And if we look at the frame here, and we look at the frame on our points, those all look fine. They look like they should be reachable. So in that case, this makes me think that maybe it has something to do with the configuration of the joints of our robot. So let's take a look and see how we can fix this. So right now, what I'm going to get you to pay attention to is the way that joint 4 is positioned. You notice how it has these two little grooves up here at the top? But if I go and I right click on my curve and I say view robot at target, that axis has flipped upside down. So that means my configuration is off, because it's completely flipped joint 4 upside down between those 2 points. So let's right click on this and let's try adjusting the configuration and see if there's a configuration where that joint doesn't flip over. Now in Robot Studio, it's kind of weird. You notice a difference in this preview because it's always going to snap to the view that it's already showing. But if you look carefully as we scroll down through these, one of these will cause that little twitch. That little twitch there shows that the axis 4 is completely the same or a different orientation. So I'm going to say apply to that. Then I'm going to go down here and I'm going to try and do an auto configuration again. And now it's able to reach all those points. So Let's go down to the outside now, and let's change the tool in the outside. Now, of course, if I was welding, I wouldn't want to hold this at the same orientations as we have it in the past. But I'm going to go here and I'm going to say, grab all of these. And I'm going to right click on them, modify instruction. And we're going to change the tool to Mig. And again, we've got some strange happenings here. So let's take a look and see what we notice. Oh, right there, that point, number 50. Notice our tool between 40 and 50, or the joint 4 between 40 and 50 has changed. So let's flip that over so joint 4 is the right orientation in 50. Let's move, 60, we got to do the same. And 70, we got to do the same too. And now let's move along path. That looks way better. So now, let's close this. And let's try move along path in the main. Actually, now that those two are done, I'm going to show you how to get that main to show up here before, because I haven't shown that in other videos. Now that we've gotten this working here, let's minimize those parts. We can get rid of that pen TCP because we're not using it anymore. And we're going to synchronize to rapid to push this program up to our controller. And then you may have noticed beforehand, between curve and outside, I had that main here. Adding main, or to get main to come in, the easiest way to do this is we go to synchronize, and instead of synchronizing to rapid, we're going to synchronize to our station. And we're going to grab the main module, because the main module doesn't by default exist within our simulation or our solution or our station, because it's not needed for the station to run. However, if we want to make this easier to work with, it's much easier if we bring main down, because then we can add all of our routines by just dragging them to main, and we don't have to go back over to rapid and manually add them anymore. So now let's try running this. And we've got a execution error. Now, the execution error is because of a configuration error. You notice that between point 10 here, this point 10, and this point 10, you notice how we're upside down again? So let's go fix those two. I'll expand my part, curve 10. We're going to adjust the configuration. Get it to flip over. And we're going to go to outside 10, because outside 10 is upside down as well. And we're going to try this. So again, because we made a change to the station, we need to synchronize to rapid. And let's see if that runs. Nope, we've got a configuration error again. And the reason we're getting this is if you notice between this point here and this point here, we've got some access configuration errors. So in order to fix this, let's just try taking the posture here at curve 20. And we're going to copy this orientation to curve 10. And we're going to take outside 20 and we're going to copy that up to that position as well. We could also add an intermediate point to try and fix this issue. And what's actually happened between these is we've got one of these joints that's moved more than 180 degrees in a single movement. And that's what's setting the robot off. It's a lot easier to see this in a real robot than it is within Robot Studio. So we're going to synchronize everything. And we're going to try running that again. And there we go. Now it looks like, oh, configuration error again. So, to do this in a little bit more detail, we're having problems on outside 80 to 10. So let's take a look at outside 80. And let's look at the configurations. We're going to look at the configurations. We've got -1, 0, -1, 0. And if we go to 10, we've got a similar configuration. So that shouldn't be making much of an issue. So maybe our issue is between our outside and our curve. Yes, there's our issue. The outside to the curve. So it looks like I didn't get that posture applied correctly. Let's try copy orientation, apply orientation. And we're going to go with a similar configuration to outside 10. So what I'm looking at here is when I go into configurations and you see this -1, 0, -1, if you have too much of a difference between any 2 points, it will cause the robot to fail its operation. So now that we've gotten that fixed, let's try the curve. Make sure that the curve doesn't fail. And let's synchronize this to rapid. And it's automatically detected that the only thing we've really changed is in curve. But just for good measure, I'm going to copy everything over. And let's try running it again. There we go. Now we're not causing a singularity or moving too far in any one axis in a single movement. Thanks for watching, and we'll see you in the next one.